if you have just trickled in, there were some pre-event setup instructions that I emailed last night. If you have already completed them, that's great. If you haven't, please at least start to do that now. Here's a short URL to this page that has those setup instructions. We'll have some time a little bit later in the tutorial to finish these instructions, but the more that you can get done now, the better. There's a space for you up front if you want. People to hate. In my tutorial yesterday, people, like I would even try to tactically leave out handouts in the front row to encourage people to sit there, and they would go to the front row, take the handouts, and then remove them to the back of the room. So. You're stuck with me here in this small room, though. Are people able to get on the Wi-Fi? Are people able to get on the Wi-Fi? Because we are going to download some stuff, clone some repositories, okay? If you're not on the Wi-Fi, please make sure you can get on. The passcode is PyCon 2014, all one word, all lowercase. Okay, why don't we go ahead and get started? And I'll get started by way of just brief introduction. So welcome to Contribute With Me, getting started with the tools of open source development. I am very passionate about this topic. Okay, so a little bit about me and why I'm so passionate about this. So my name is Jessica, hello. I am a director for the Python Software Foundation, so the stewarding organization behind the Python programming language. I'm also a core maintainer for a couple of open source projects, including the OpenHatch project, whose logo you'll see all over the place because they are a nonprofit dedicated to lowering the barriers to entry to open source contribution. So very relevant to the mission of this tutorial. I'm also a core maintainer for Twisted, and I've done a fair amount of core Python contribution. I'm also, in a very recently previous life, I was an organizer for Boston Python, which is the largest Python user group in the world. I happen to have moved to San Francisco as of a week and a half ago because my company was acquired, as seems to happen to everyone. So now I'm getting to the San Francisco folks. But I would classify myself as very involved in the Python community and the broader open source ecosystem. I've also been a Google Summer of Code mentor and a GNOME Outreach Program for Women mentor. We are honored to have a number of super talented and experienced open source folks helping at this tutorial. Do you want to give a brief intro who you are and maybe some open source stuff that you do?
Sure. So my name is Adam Fletcher. I work for Google as a site reliability engineer. I also previously Boston, Massachusetts, now in San Francisco. And I like to do a lot of variety of small open source projects.
Deb Nicholson, I work at the Open Invention Network, which is a extensive patent pool for Linux stuff. I contribute to the new media guideline, which is a Python project to create a decentralized representation for Flickr and YouTube. And I'm also and I managed to also talk myself into being a Boston Python.
Yeah, awesome.
John Morrissey, I work for Harvard. I work with a lot of open source projects for infrastructure projects, a lot of servers, Java entries, things like that.
Cool, thank you so much for helping. We have all kinds of things to talk about today. We are going to talk about things in 4 broad strokes parts. First, the life cycle of a bug, some hands-on practice right here, right now on the tools of open source development, then contributing to some toy projects to get used to the mechanics, and then pointing you in a really good direction for contributing to actual open source projects. And it's worth sort of dwelling for at least a minute on why we might even bother to spend time doing this. Like, why contribute to free and open source software? And at least speaking for myself, there are a bunch of reasons. So one reason is that the community and the open source tools that I use every day have given me a lot, and I feel compelled to give back. So, I want to give back, and that's one reason. Another good reason is that I really enjoy meeting and interacting with people in open source communities. They're often really smart, and they know things that I don't know, and I get to learn from them. I can say definitively that I learned more about software development contributing to open source projects than I learned in school, and possibly even more so than on any job that I've had. Because of the decentralized development nature of open source projects, it really instills some good disciplines in you about software development. So you meet good people, you learn things. It instills skills in you that translate to workplace, so to a software development job. It will also help you get a software development job. I can say as an engineering manager that I really don't care about your resume. What I really do care about is being able to see proof of your capability through open source projects that you've contributed to. I can look at the code myself and see what you're capable of. Then it's also just kind of fun. Adam, in addition to having also just moved to San Francisco with me, he's my husband, and we have a lot of open source programming dates where we contribute to projects together. Anyway, yeah, so it's fun. During this tutorial, we are going to sort of emphasize making code contributions because it's easy in the context of PyCon to do that, but it's worth remembering that there are a lot of ways to contribute to open source projects, and they're all important. Like, code is not the most important thing. These work together holistically to make a strong community and a strong project. So this includes documentation and helping new users, having good onboarding for new users and new contributors to the project. This means things like artwork and translations. This means maintaining the infrastructure around the project. Like, if you ever thought about Python, Python is a huge project. It has a lot of people contributing to it and requires a lot of resources to maintain. As we'll see, you have to test Python across a range of platforms, and there's a website to host the Python distributions that people are downloading, and there's a lot of work that goes into this, and it's basically all volunteers. So when we say contributing to open source software, we mean across a broad spectrum of areas. All right, so here's our game plan for today, as I said. So we're going to start with the life cycle of a bug, and our goal is to sort of get a good conceptual underpinning for actually practicing the tools. And I'll give a quick note on bonus material here. So some of what we're doing when we practice, like how fast you get through it, is somewhat going to be dependent on how comfortable you are with your development environment. So some people will finish early and some people won't, and that's totally fine. We have lots of bonus material to keep people who finish early occupied. So use this time as effectively as you can. If you finish something early, check out some of the additional resources we have for you. I'll repeat this link all over the place, but open source bonus. Okay, number one, the life cycle of a bug. So we're going to go through this whole cycle together and get a big picture. There are at least 6 major categories that I list here in order. So reporting, triaging, patching, testing, reviewing, and then resolving the bug. And step number 1 is sort of reporting and triage. Let's say that we think we have found a bug in Python. How do we discuss this with the broader community and come to a consensus on if this is a bug or not and how to get work started on it? And there are 2 main ways that folks communicate in open source projects. The first is through mailing lists, and the second is through a text-based real-time chat tool called IRC. And we're going to use IRC ourselves together later today. But mailing lists and IRC are sort of the 2 big ways to communicate. And just to give us a really concrete sense of what that looks like, so here, for example, is the actual Python dev mailing list archive. This is a mailman mailing list. Mailman is written in Python. And it can look a little bit arcane, and it can look a little bit overwhelming, but you learn to pattern match where the useful information is. So we're looking at, here now we're looking at sort of the month-by-month archives, and we could drill down on, say, April for Python dev, and this would show us all of the emails on this mailing list for April related to the development of Python the language. And people are talking about all kinds of interesting things, often all kinds of arcane things. But a lot of the things they're talking about are, like, should we make this change? Is this actually a bug? I think I have found this thing. What do you all think about it? So it's really a dialogue about how to move forward the language. And then similarly, you know, it looks a little bit different. This is a Google group, but this is how Django developers develop. They mostly develop centered around this mailing list, where again, they're, you know, pointing out bugs or asking questions about potential new bugs or features. So here are mailing lists. And then the other big way of doing things is in real time on IRC. And I see that I've lost my network connection, so let me get back to this. Oh, SSH, what are you doing? Do I? Am I offline? No? Did I block port 22? It's not hanging. Well, my intention was to SSH to a machine where I have an IRC screen session hanging out. But this is not. Yeah, well, okay, I don't want to derail us too much. Let me try something else real quick. Okay, well, we will look at IRC more in a couple of minutes anyway, and we're going to hop on IRC together, and we'll figure out in the interim what the deal is. But IRC is a way to communicate in real time about bugs, about issues. Okay, so the first entry point into a project is often through discussing potential bugs or you know, helping users on IRC or on the mailing lists. And so if we think we found a bug, the next thing that we will learn to deal with is sort of how to report the bug and confirm that it is a bug on an issue tracker. An issue tracker or a bug tracker, people use these terms synonymously, but this is where we keep track of bugs that we want to fix, tasks that we want to accomplish, features that we want to add, so that we don't forget to do them, and so we know who is working on them or which things are not actively being worked on. And bug trackers, again, can look, they take a couple of different form factors, but they all carry approximately the same information. So here's one example. Here's the Python core bug tracker. And this can be sort of it looks overwhelming when you first see a bug tracker, but we'll see that there are sort of common characteristics of all of them, and you learn to pattern match what the important parts are. So here is, you know, bugs.python.org, and we see that each entry represents a distinct bug or feature, and each bug has a unique number, and it has a title, a descriptive title. It has a status. Is it open or closed or maybe being worked on? Who created the bug? Who, if anyone, is currently working on it? And what type of bug it is. Is this a bug? Is it a behavior problem? Or is it a feature? Is it an enhancement? Or perhaps something else, like this is a security bug. Yeah?
How do you know if you're not creating a duplicate bug?
Ah, that's a great question. And we're going to go through the exercise of creating our own bugs later today, but you do only want sort of one main bug for a given actual problem. And so the way that you avoid creating extra bugs is that you'd be sort of careful to search for if an existing bug exists around plausible keywords for the problem, or you might ask. You might ask on the mailing list or IRC, hey, I saw this thing. It just happened when I upgraded, so maybe other people have already noticed this, and there's already a report on this, or should I actually report this? Is this new? Yeah. People should definitely raise their hand and ask questions, by the way, if you have questions about any of this material, so it's designed to be interrupted. Okay, so there's some activity metrics as well. And so that was core Python. Here's another example, you know, skinned a little bit differently. This is for Django, but we see pretty much the same information. There's a ticket number, there's a summary, it has a status, an owner, is it a bug or is it a feature? Is there a particular release of Django that we're targeting getting this thing in? And then one more example, it looks a little bit different. It's hosted on this thing called GitHub, which we'll talk about and use later, but also an issue tracker where we have issues that have numbers, and you can drill down on a given ticket to see the full discussion about it. Cool. Okay, so we might talk to folks on mailing us an IRC. If we think that we found a bug, we might report it on an issue tracker. Other people will do things like confirm that it's actually a bug. Like, let's say I'm on my Mac running a particular version of OS X and a particular version of Python, and I think that I found a bug in Python. And I've searched the bug tracker, and I don't think anyone else has reported this, so I create a bug about it. Other people will come along and they will help triage the bug. They'll help classify it, confirm that it's a bug, and maybe restrict the scope of the bug to the platforms that are actually affected. Like, maybe someone will say, oh, I saw you open this bug, great, thank you. I didn't have this problem on Windows, so it's possible this is a Mac-only bug. And then other people will jump in, helping to refine the problem space and possibly suggest solutions, or suggest if there's a bug in your environment instead. I mean, that concept of like categorizing it, is it a bug, is it a feature, restricting the scope or clarifying the scope of the problem, is called triaging. And triaging is a really valuable part of contributing to an open source project. And if we find a bug, we really want it to get fixed, probably. And there are ways to maximize the probability that a bug gets fixed. The way to do that is to write a good bug report. And there are some really easy steps to writing a good bug report if you think that you found a bug in your favorite open source project. If at all possible, it should contain a short self-contained example of the problem. So like reducing it to its very essence, like in code form if possible, so other people can readily reproduce the problem. You should say what your inputs were and what you expected to happen, and then what actually happened. I expected, like my input was the number 1, and I expected the output to be the number 2, but instead what actually happened is that my system crashed. That's bad. And depending on the case, you may also want to, depending on the bug, it may make sense to provide a lot of system details, like I am running Linux version Ubuntu 12.04, and Python 2.7.6, and GCC version 3.5. Depending on the context, in general, the more information you can provide, the better, because it helps clarify the scope of the problem. Okay, so we want to write good bug reports, because when you write bad bug reports, people ignore them, because they're too hard to figure out. And here are some examples of good bug reports. So here's one. This is in the Django project. It was actually open for quite a while before it was most recently acted upon. But this is actually a really good bug report. So if we look at this, so this person, Gary, reported it, and Gary said, I think there's a bug here. Here's my code. So here's my short self-contained example. Here's my code. And depending on some environment setup, what actually happens is it looks like this, or it looks like this. What I think should happen is that it should look like this. In other words, here's a summary of what I think the bug is. Here's my problem description. Now let's go fix it, right? And there's probably some categorization of where it applies. When he filled out the bug, he can say things like, oh, this was a problem in this particular version of Django, on the master branch of Django. Cool, awesome. This is a really detailed bug report. It's very easy for people to start making progress on this because it's been clearly articulated what the problem is. So this is great. This is a good bug report. Here's another example. And this, the actual bug looks kind of arcane. It's like some Windows bug for Python. But another really good example because it contains a 2-line reproducer. So like if you were triaging this bug and you had a Windows machine, the idea was you could take those 2 lines and run them in Python, and it would cause this crash. It would be very easy for you to confirm that this was a bug or not. So that's great. A 2-line reproducer is like a beautiful thing for the core developers. Cool. So reproducers, concise description, expected inputs and outputs, what actually happened, lead to a good bug report, which leads to your bug fixes getting merged. Awesome. Okay, so we know where to report bugs in issue trackers. We know how to triage them in issue trackers. We know how to write good bug reports. If we've confirmed that there is a bug, how do we go about fixing it? Well, at a high level, what does it mean to change Python? So like Python code lives, it's code that lives in various directories, in various files and directories, and it's stored in a revision control system, which we'll learn more about or use hands-on a little bit later. So it's stored in a revision control system that makes it easy to track what changes have happened and who made them and why. And if there's a bug in Python, I'm going to check out a copy of this source code, and I'm going to make changes. If it's a code bug, I'm going to make changes in the code, and then possibly do some other things like write tests. And then I need to communicate those changes out to other developers so that they can evaluate the changes to see if they're good changes to fix the bug. And there are some tools that we use to standardize the way that you express these changes. Because like an inconvenient way of doing this would be if I said, hey, I found a bug in Python, and all I had to do was change line 3 of this particular file. Here is all of Python, including my one-line change. Like, we want a more succinct way of representing that, right? So that you can run, you can easily take my changes, apply them to your copy of the code base, and now you are running the sort of the patched, the up-to-date version, the fixed version of the code. So the concepts that allow easy sharing of changes of code, the underlying format is called a diff, and we apply this diff using a tool called patch. And I'll show you what this means by way of an example. So, where am I? Here we go. Okay. So here's an example. Let's say that I am a budding lyricist. I'm a budding poet, perhaps. And so there's this really great sonnet by this guy named William Shakespeare. And I'm like, okay, I like this sonnet, but I want to put my, I'm gonna go to the coffee shop later today, and I want to put my own twist on this sonnet for my beat poetry at the coffee shop, right? So I'm gonna make a couple of changes. So here's Willie's sonnet, and then here's my version of the sonnet. So it's pretty similar, although I am now the author of it. And to succinctly, and we can look at exactly what was changed in the text using a utility that's installed on all of your machines if you've done the set of instructions called diff. And diff-u, the u means unified or universal, and it's a way of specifying the change, but just do it because it's the way that everybody does it. So diff, and then the original file, and then the new version of the file will tell us succinctly what was changed. There's some sort of metadata here. The original file is called sonnet. The new file is called my sonnet. We have minus signs and plus signs. Minus means the line was removed. Plus means the line was added. So in this case, we change beweep to betweet, because it's 2014 and we're going to use Twitter instead. We talk about posting on Facebook instead of cursing our fate, and then I make myself the author. Importantly, this is actually we've actually omitted stuff that is not near to the code that was changed. So like these little @ signs represent that there was more text that we don't really care about because it wasn't changed by my changes. Like if you have a version of the sonnet, that part doesn't need to change. You only need to care about these minus and plus signs. So what is this diff? It is what was changed, what was added or removed, plus enough context for a program to be able to figure out where to apply your changes. So there's a utility called diff that generates this thing called a diff. And there's a utility called patch that applies diffs. So that will take a diff and apply it to your version of the code so that your version of the code is now up to date to my version. And we can actually do that here. So I can save this diff, to whatever, sonnet.diff. We can save this. It's exactly what we just did, only now saved in a file. And I can take this, and I can move it over to Adam's project. Adam's going to join me on this beat poetry extravaganza. And so I can go over to Adam's version of the project, and if we look at his version of the sonnet, he has William Shakespeare's version. But I can apply my diff so that he will have my version. And the tool to do this is called patch. So patch takes diffs and applies them to code. And the syntax is kind of funny. We don't care about the syntax. We can always look up the syntax. But this is the syntax for applying my version of my changes to his version of the sonnet. So patch takes the diff and applies the change. And now if we look at Adam's version of the sonnet, we see that he has exactly my changes. So this is really cool, because if you have Django or all of Python, you can use this tool to generate a very succinct change plus a little bit of context that expresses a bug fix or a feature. And this is the underlying format that all of these higher level tools that we're going to use later today use. So we need to get comfortable with what a diff looks like. You know, this format of minus signs and plus signs representing what was subtracted and what was added, we need to get comfortable with because we're going to use it in other tools later on. Cool. Okay, but why do we care about diff and patch? We care because when I make a change to my version of source code, I need to be able to communicate that change to you. The way that I generate a succinct version of that change is with diff, and the way that you apply that change to your version of the code is with patch. Any questions about that? Yeah.
How do you know you're not creating something else?
Oh, that's a good question. We'll talk more about that now, actually. Okay, so we found a bug in Python, say, and we opened a bug report on the issue tracker about it, and people triaged it. They confirmed that it's a real bug, and it exists for them too. And we even knew how to fix it. So we got a copy of the source code, and we'll talk about how to do that in a bit. We got a copy of the source code, and we made some changes, and we can express those changes using a diff. What we need to do before we really do anything else is that we need to make sure that we haven't broken anything by running test suites, and make sure that these changes that we've made apply cleanly for other people. So a couple of pieces of the puzzle here. So one thing is, how do I get the Python source code in the first place? We haven't really talked about this yet. So the Python source code or the Django source code, or really any open source project that people collaborate on, is stored in a revision control system. And that's a revision control system, often called a version control system, is just a fancy word for the source code and some metadata around it to help you track what changes were made and by whom and when. It's a lot like Wikipedia. If you've ever looked at the history of a page that was edited on Wikipedia, and you can see, you can compare the different revisions and see who made the changes and when. It's exactly like that. And this is really important because when you're having lots of people working on code together, you need to keep track of why changes were made, right? Like who fixed this bug, and when and why. You fixed the bug, but actually your fix was broken. Let's look back at what the change was so we can figure out the true fix to the problem. So for collaborative development, we're always going to use a version control system. And it's just like Wikipedia. So let's take a look at an actual example of an open source project that is stored in a revision control system. A really popular revision control system these days is called Git. There are lots of them. Git is kind of winning right now, so we're going to look at one that's stored in Git. They all fundamentally have the same underlying model for sharing changes. Okay, so we'll leave our sonnets for a little while. And if I go over to Git, so I have a project called Wordplay. It's kind of a fun project, actually. It's if there's a Scrabble cheater that you can use to cheat at Scrabble, which I use against my family all the time. So like given a rack, it'll tell you the best words that you can play and their Scrabble scores. So kind of a fun project. And I track, people have collaborated with me on this project. So I store this project in Git, which means that the source code and some extra metadata is stored by this Git tool. And the way that I make changes is sort of through this Git tool. We're using these underlying diff and patch utilities, but sort of with Git layered on top of them. You'll see what I mean in a second. So okay, so we have the code, and the code looks the way that Python code looks. Like the code is totally normal. But if we use Git, we can examine some of the history for this repository. So the most basic thing that I can do is I can run git log to give me a log of all of the changes that have been made. And so the top is sort of present day, and going down is going backwards in time. And if I arrow down, we see a bunch of these commit things, these yellow commit things, and a bunch of authors and dates, until we go all the way to the beginning of time. And each commit has a unique ID, so that big long string of characters in yellow, that uniquely defines it so that it's a handy reference. If we want to talk about a particular change, we can use that unique ID as a reference. There's an author, there's a date, and then there's a message, a commit message associated with a given change that expresses why we were making that change. So you see, I've made a couple of commits, but someone was working with me on this. So Robert also had a commit on Sunday, April 6th, that made this program Python 3 compatible. Awesome. So collaborating on this project.
So
Yeah.
IDs are unique within like all of Git.
Good question. So there are so many bits in this. So this is called a commit ID. It's often called a SHA-1 because that's how it's generated. So if you hear the term SHA-1, just know that's a synonym for a commit ID in Git. There are so many bits that are generated that there are basically never collisions. So this is probably unique across the planet. And this number is actually this commit ID is actually determined by the content of the change, the whole history of the content of the change. Actually, it's kind of cool. So let's actually drill down on a commit ID though to see what it actually is. So okay, we can look at the most recent one. So the latest commit, the one at the top. So all I'm going to do is I'm going to copy this commit ID, and I'm going to run another git show on this ID. And if I run git show, we see, lo and behold, under the hood is our diff format. So Git is doing some of the work for us, but we see this is exactly what we saw before. The file that was changed was Scrabble cheater, and then what was removed was this line, what was added was this line. It's even nicely colorized for us. Cool. So what this means then is that a commit in Git translates to the diff. So there was source code version A, and then on top of that source code version B, and the differential is represented by this commit, which we can examine using git show. And what's really cool about this, actually, is that that's all there is to it. So if I look at git log, if I start at the very beginning, and I git show on each commit in turn, like each of those diffs stacked on top of each other eventually produces the present day code. Like that's all there is to it. It's just the original code and then a series of diffs represented as commits. So that's pretty awesome. I'm going to shut this program down so it stops bothering people / sharing work secrets with you and the internet, because this is being recorded. That's no problem, guys. Okay. We'll edit that out, I'm sure. Okay, so Git is a revision control system that we use to store source code and allows us to collaborate because we can succinctly share our changes over Git, as we'll see, and it succinctly represents the who, the how, and the why of changes. Any questions about Git? Cool. Okay, so the question was, like, how do we make sure we didn't break anything? So if we want to make a change in Python, what we do is we get a copy of the revision control repository containing the Python code. We make some changes, and then we test it. Because Python has test cases. And we want to make sure that not only do we not break anything, we don't break anything for anyone across any supported computing environment for Python. So we can see some examples of this. So actually, CPython itself. So this is the CPython repository. Oops. As it happens, CPython is maintained with a different version control system. Like I said, they're basically all the same. It happens to be called Mercurial, which is stood for by HG, but there's an HG log command that looks exactly the same. There are these unique IDs that represent changes. No big deal, the format is slightly different. But okay, so we've checked out this CPython source code repository, and then there are a ton of tests. So if we look in lib/test, there are just like zillions and zillions of test files. And we can run them. And the way that you run any given test suite for a given open source project, like there's some documentation on how to do this. In this particular case, the way that you run it is with this incantation. The details don't super matter because under the hood, you're just running a bunch of test cases. And we'll look at what some of these look like. So people who develop CPython, they are regularly running this stuff, like lots and lots of tests, to make sure that we haven't broken anything in any corner of the code base. And we won't sit here watching all of these run, but we can have a look at one of these to get a sense of what it looks like. So if we've used the string module before, you know, you can uppercase things, you can lowercase things, you can split strings, yada yada. Here is a file containing a bunch of the tests for the string module in Python. And have folks here used a unit testing framework in Python already, like for work maybe? Okay, cool. So this is a really cool idea. So we'll spend a couple minutes talking about it. So let's say that you have a bunch of code and you want to organize how you're going to test all of it to make sure that you've tested everything. The primary, the built-in way of doing this in Python is with a module called unit test. And what you do is you import unit test and you have classes implementing the unit test case class. And so you might have a class for each major bit of functionality within a module. So like in this case, we have a module test class. We have, let's search around here. Okay, we basically have one giant class implementing or subclassing unit test that test case. And then within each class, we define a bunch of test underscore methods. And each one of these, each test underscore method represents like a distinct test that is run by the test harness. So if we look here, we have one unit test. We would call this a unit test. So test underscore adders confirms that the string module has a white space attribute, and it has an ASCII lowercase attribute, and it has a punctuation attribute. We see the one below it implements, so this test cap words is testing that when you run the cap words method on a string, the expected thing happens. So like given the lowercase ABC, we would expect it to capitalize the first letter in each sort of word, if you will. So a bunch of tests for capitalizing things, including like some weird cases, right? There are tests for string formatting, tests for string conversion. So all of the things that we do day to day in Python, these all have test cases inside the CPython source code that are run every time people make changes to make sure that nothing broke. And then, so to summarize the structure here, you have some sort of unit testing framework. You group related bits of functionality by class, and then inside a given method, you test a specific thing. Like you test that you can capitalize words correctly. Or you test that string formatting works correctly. And you assert things. Like I assert that the way that this is supposed to look is like this. And if it doesn't actually look the way it's supposed to look, then the test fails. And when tests fail, we know that we've broken something. Cool. So that is how you make sure you don't break things. People write lots of tests, and then you run them regularly. And if you don't have tests, then you have no idea if things are broken or not. So not having tests is a bad idea. But it gets even more serious than that. So like Python is an incredibly important project that lots of companies and lots of other projects rely on. So it's not sufficient for the test to pass on your machine after you make a change. Like Python needs to continue to function properly on all of the supported platforms. So the way that we deal with that is we use some test automation frameworks to like say, hey, run the test suite across a bunch of different platforms all at the same time in parallel to make sure we haven't broken anything. So here's one example of this. So here's an example of the buildbot build matrix for the Twisted project. And green is good. Green means that things are passing. Red is bad. It means that things are failing. And then these are different build numbers, but this column here is representing the different build platforms. So we see that they're running various versions of Linux and Windows and OS X with maybe different versions of Python, with maybe other environment customizations. The matrix of things that you need your project to support. Because you got to make sure that they all pass. Yeah. Purple means there was an exception. It probably, in this particular case, it means that okay, so the way that these are running is that there are actually like lots of pieces of hardware that like this centralized brain is pushing out commands to. Sometimes the brain, like it tries to push out a command and the guy wasn't listening for some reason. Maybe there was a network blip, maybe the machine rebooted, whatever. This represents I couldn't talk to the machine. Yeah, good question. Here, just to give you another sense, another view of this, they tend to look similar. This is Python, like CPython's build bot as well. I see that lots of things are red, which is not super encouraging. I'm sure there are good reasons for that. And this interestingly, so the top is like present time, but then we can actually look backwards in time as well to look at specific builds. So that's kind of cool. Yeah?
What if the bug requires modification to the test files? Like, is that the same thing?
Yeah, that's a really good question. So like, let's say that, well, there are a couple of cases in which this might happen. So let's say that I found a bug, and part of the reason why the bug exists is because there were no tests for this functionality. Like, nobody caught that this was a bug because there were no tests for it. So a thing that you might do, or that someone might do in conjunction with your bug report or your bug fix, is add tests for this functionality so that it'll never break again, hopefully. Like, now we're testing it so we won't break it again. Sometimes tests are wrong. Like, the tests have to correctly be testing the thing they're supposed to be testing for the tests to be meaningful. So sometimes there are bugs in tests, and like the whole bug report is that this test didn't actually do anything. Yeah. It's like, who tests the testers? Sort of a, yeah. Other questions? Okay, so when we think we found a bug and we fix it, before we can really do anything else, we need to confirm that at least we don't cause anything to break, and potentially we add additional test coverage for this bug on our local environment. Additionally, once the code is pushed out to other people to evaluate, it may additionally be run on a broader set of testing environments to make sure nothing broke for Windows users as well. Yeah. So I think this is a couple of questions in one. So one question is like, I'm new. I would like to contribute to an open source project, but I'm new to the code base. What can I realistically make judgment calls on that people will listen to? And then another question is, like, at some point there's sort of a gatekeeper, or there are some gatekeepers, right? Like, Python needs to maintain incredibly high code quality, so we need to have processes in place that limit when code can get changed. Like, there's a review process, and some people who have demonstrated over time that they understand the code base and sort of can be trusted to commit the final changes that get pushed out to everyone else, they're the only people who can actually make the official changes. Like, we can produce bug reports and we can produce patches, but ultimately they need to be evaluated and applied by perhaps the core maintainers of the project. And then we'll see with some of our, when we do some hands-on stuff, we'll see that there is sort of a notion of project ownership. And it's sort of at the discretion of the project who has the ability to do what. Can everybody commit code, or can only certain gatekeepers? Okay, so tests. We have fixed the bug. It doesn't even fail the test. We even added some new tests to ensure that this bug never surfaces again. Awesome. Now what? Okay, well, the next thing that happens in the vast majority of cases is that someone else needs to look at your code too, for a couple of reasons. One is in case your fix is not, like, maybe you forgot to run the test suite. And the person who's looking at it notices that actually something does fail. Or maybe they notice that this isn't quite the cleanest way of implementing the problem. So there's sort of like a correctness and process sanity check by having someone do a code review for you. Oh, maybe this documentation that you added is not quite right. Oh, I would test this a little bit differently. And it's a dialogue to improve the code that ultimately gets shipped out to everybody else. So this concept of sort of having a dialogue around your changes is called a review. And reviews are awesome. If you don't do code reviews at work, that's really sad. And there's a lot of people who study this stuff, and there's very strong scientific evidence that code reviews produce better code quality and save you time. And actually, one of the things I really appreciate about contributing to open source software is that it has instilled a very positive code review perspective in me that translates to my work. Okay, so code review, what does this look like? So here's an example of a documentation request. So someone reported this request, and they say, hey, we need to add some documentation. And then someone started working on the documentation, and then they put it in review. They said, hey, I have made some changes to the code base, and I've run the tests, and I've gone through the process checklist. The documentation looks good. Can someone else do a review? And then someone does a review. They say, oh, there's a slight formatting bug. Can you update your patch to fix this formatting bug? And the person says, yep, no problem. I made the changes based on your feedback. I'm going to put it back into review. And then I come along. I'm like, hey, thanks for working on this patch. Awesome. I think this looks really good. I have a couple of really small points. After you make these changes, this is ready to be merged into the code that everyone else uses, like the code that represents the project. And then and then we'll talk about what merging means, and then the code is ready to go. The code is ready to ship out. And so this is a pretty typical code review. A patch looks pretty good. There are a couple of things that need tweaking. Someone reviews it and there's sort of a, it's a cycle. There's sort of a patch review cycle until everything is up to snuff, and then it's ready to go into the next stage. Here's another example, slightly different form factor. This is on GitHub of code getting reviewed. So there's the initial bug report with a bug. Let's see, sorry, with a diff. So here are some changes. We see that those plus signs. So this is just our underlying diff format. A test was actually added. So cool, we love tests. There are some comments on the test. There's some comments like, oh, we can actually do this test slightly differently. Why don't we tweak that a little bit and add some documentation? And then we say, hey, you're right. That is a better way of doing this. Awesome. Now this patch is ready to merge, to commit for everybody else. So reviews, they improve code quality, and they promote sort of mind share across the project. So now at least two people know what was going on. The person who wrote the code and the person who reviewed it, and that's great. Okay, so review. And then there's one final step, which is we have this diff that lives on my local machine, but we need it to now live in the repository that everyone else is using for this code, right? And so using a tool like Git, we'll use that underlying patch utility to apply this change to sort of the master copy of the repository, and then other people can pull these changes into their local copies. And so that's what happens. After a review, someone who is a gatekeeper, someone who has the ability to commit changes to sort of the master copy of the repository does so, and then everybody else is able to pull in these new changes. And that is the life cycle. So we think we find a bug, great, we report it in an issue tracker. Maybe we talk about it on the mailing list or IRC first. Other people may triage it. Hey, this is a bug, I can confirm this, and it even happens for me on Windows. Someone fixes it. So they have checked out a copy of the source code using a revision control system, and they will make some changes, and they might express that change using a diff, which can be applied to someone else's copy of the code using a tool called patch. Or we might use the sort of higher level utilities built into the version control system to express those underlying changes. We produce a patch. We make sure that we don't break any tests, or maybe we add new tests. We submit our patch for review. People review it. There's a dialogue around improving the patch. When everything is good, we resolve it by committing the code, updating the issue tracker. Now everyone gets to enjoy this bug fix or this new feature. And that is how things get done in open source projects. Does anyone have any questions about the life cycle of a bug? Yeah? Yeah. No, that's a good question. It sort of depends on the project. There is some process, like there is some written documentation about how to contribute that specifies when you need to run the tests, when you need to add documentation, what a review looks like, and who ultimately has the ability to commit the changes. So it's a shared responsibility depending on the project. Other questions? Cool. Now we're going to shift into phase 2 of this talk, which is actually practicing some of these tools. So first things first, if you have not completed the set of instructions from the pre-event set of instructions, please visit this link and do that. So this is going to have you installing a couple of command line utilities and IRC. So bit.ly/open-source1. And then once you've done that, we're going to do two things. You've created an account on openhash.org, and they have these really nice training missions that are going to help us practice the tools that we talked about. So using these diff and patch utilities to express code changes, and then also learning a little bit about that Git version control system, which we're going to use extensively in the context of GitHub later on today. So our game plan for the next 10, 20 minutes is first, get our basics set up, open source 1, and then go to the Open Hatch training missions. Everyone know what they're doing? Awesome. We're going to cycle around and make sure we can help people.
Yeah, if you have any help, raise your hand, we'll come over. We'd like to.
Do you have your computer? This is good, yeah. Yeah, it was never well. Okay, I have a brief interjection here. So whatever network blip was happening is over, and now at least I'm able to connect to IRC. So I'm going to give a quick spiel on how IRC works, and then we're actually going to use this to be this is going to be the main way that we communicate with ourselves about questions that we have about this content for the next 2 hours. So so this is an IRC client, and IRC is a real-time chat tool that many open source projects use to talk about their projects. And this can look a little bit arcane. I mean, IRC is like this horrible protocol from the 80s, but it has persisted in popularity because it fills a niche that is satisfying to people. So a couple of things going on here. I have connected to a particular IRC network, in this case the Freenode network. The Freenode network hosts a lot of open source projects. So like Python, Django, PyPy, like they all use Freenode as their main, IRC. They use the Freenode IRC network to host their IRC channel. I am sort of idling in a bunch of different channels here. The bright white means that there are messages that I haven't read in these channels. My username is JessTess. And you have or you will install an IRC client. The form factor may be a little different, but the operations are essentially the same here. You can cycle between channels. Here we're in the PyCon practice channel, which is the one I recommend that you all join. This is going to be where we discuss stuff. You can do anything here. Like, there are no mistakes in our little PyCon practice channel. So everyone say hi. Like, you're on screen. Here's your opportunity to do something crazy. Yay. Okay. Exactly. Here's another one. So PyCon actually has an IRC channel. So if you join #PyCon, various people are saying things about PyCon. Here is the Python dev channel. So here are people, like, this is really happening. Like, this is actually how Python gets developed. People are talking about a particular problem on IRC right now. And let's see here, I'll flip back to, here we go. So here's me. A couple of things. So this is a broadcast medium largely. So anybody can join this channel, and when you talk, everyone in the channel can see it. You can emote things. So I could say /me dances, and I'm dancing, or at least an ASCII representation of me dancing. You can have private messages with people. And there's an etiquette around this. Often you sort of ask in a public channel if it's okay to start up a conversation with someone. And I think what you'll find is as you hang out in various IRC channels, you'll just get a sense of what the community protocol is. It's different for every community, but you just hang out for a little while and you get a sense of what it's like. So can someone, are either of you on IRC right now? Can one of you get on IRC so I can talk to you? Okay, so let's see here. Or someone who already knows how to. Does someone want to send me a private message? See if anybody knows how to. He might beat me to it. One thing that I can do is I can talk to specific people. And the way that I sort of direct communication in this broadcast medium to a particular person is to type in their name and then a colon and then say it. And like the IRC clients will even auto-complete people's names for you. Can someone do that to me? Someone try to talk at me. Great, yeah, so see, these show up differently. Like, this helps call to attention the fact that someone is talking to me specifically. And here, we have one, this would show up in red if I weren't focused in this channel. And we also have another red one here, so let's check out what that red one is. Here we go. So here, this is a private message. And this is keyed sort of subtly by, it says who I'm talking to this person, and it's in red. That means that it's a private message. So this is how you can have one-on-one conversations with people. So you can use IRC, you largely use IRC to talk in groups around some topic, but you can also have private conversations, being conscientious of the fact that there's some amount of etiquette around talking to people. Okay? So, as you work through some of these open hatch training missions, as we go through some of the GitHub challenges later, if you get stuck on something, ask an IRC. Like, this is good practice, because this is really the way that work gets done in the vast majority of open source projects. Okay, any questions about IRC? And if you're interested in this stuff, like you can, there's Adam. So I'm using a particular IRC client called IRSSI. It really doesn't, the details of it don't matter. This happens to be the way that it looks, and probably looks super ugly actually. It looks really arcane, and probably a lot of you have like nice graphical clients. There are some benefits to doing it this way. We won't get into that. But there are also like lots of things you can do with IRC, and there are lots of customizations. And if you get really into IRC, there's extensive online documentation about all the various things you can do. But the main things you need to know are how to talk to people one-on-one, and probably how to direct messages to specific people, and then how to emote things. And that's really the 95%. Is everybody able to get on IRC? Cool. Excellent. Okay, so after that little interlude, we're going to go back to working on the diff and patch mission and the Git mission. And if you have any questions, ask on IRC. Okay? going through these practice projects is to not sweat the details. Like, don't feel like you have to memorize this stuff. It's to get a sense of how the process works, and having seen it once before, like the next time you do it, it'll be way easier. So we're really focusing on the process here. And then a couple of other tidbits about IRC as you're working and using IRC. Some IRC etiquette things. So it's really common to sort of want to ask for help on IRC. So a couple of things to keep in mind if you're asking for help. Number one, you should just ask your question. Don't be like, hey, is it okay for me to ask a question here? Because the answer is yes. And you just ask the question and you save a round trip on people answering that. Another thing is that it's possible that the people who can help you are in Australia, and it's the middle of the night and they're asleep. So just sort of be patient. Like sometimes you just have to keep this window open and hang out for a little while until someone comes along and can help you with your question. So giving 1 or 2 minutes is not enough time. Sometimes you just need to let it hang out, and you just hang out, get a sense of the channel, and someone will come along and help you, once they actually see it. And then one other etiquette thing is that it's not polite to paste like giant chunks of text or code into IRC because it fills up everyone's windows. If you have a lot of code that you want to share with someone, you would paste that code elsewhere and provide a link to the code in IRC rather than pasting it directly. Any other tips you want to share?
I didn't know if you wanted to tell people like where to
Yeah. Oh, so an example.
maybe not your Facebook wall, but
Oh, well, if you want to post code to your Facebook wall, I would be a great trend. I would support that. But an example of this, or maybe the most prototypical example of this, is a tool called Pastebin. And this is just a way to paste code that other people can use. So like maybe I wanted to share a bunch of libtest test string with you all. I could copy this. I could create a GitHub, a Pastebin link for this. I can even syntax highlight it if I want. Get fancy about it. Produce a paste, and then I could paste this into our IRC channel. So that would be the more polite way of sharing a large chunk of code. Any questions about IRC etiquette, things like that? Cool. So quick interjection here. Raise your hand if you're done with the diff and patch missions. The diff and patch mission? Okay. Hopefully. Have you checked out our bonus material? Remember,
Never mind, I wasn't going to find that really easy. I'm glad you searched for it.
so folks, a brief interjection here, because we had a really good thing come up that is a good sort of real world open source moment. So gentleman in the back, what is your name? Tim. Tim is on Windows, and he discovered while working through the diff patch mission that it recommends that you use wget to download some files. And wget does not exist in git bash. So when he tried to run that command, it didn't work for him. And so this would be an opportunity to see if we can create a bug report in the OpenHatch bug tracker. So this OpenHatch software that you're using is open source software. It has an issue tracker. Here we are. And we could open a ticket for it if we wanted to. Now, before we open a ticket, what we should do is see if this ticket already exists. So the bug was on Windows, one of the missions asks you to use wget, but wget is not installed. And so a reasonable thing that we might search on is wget. So if we search on this keyword in the bug tracker, we see that a couple of things match. And actually, it looks like there's an issue that was open 1 month ago that's pretty related to this idea. It says, we use git bash, but we've discovered that git bash does not come with wget. It does come with a similar tool called curl. Let's recommend that we use that instead. So awesome. Tim or anybody else on Windows, if you want, you could comment on this ticket saying, I can confirm that this is a bug for me on Windows and that this fix would fix the problem if you do in fact have curl installed. So you could totally help triage this bug if you wanted to, and I would encourage you to do so. And then for everyone else, if you have found any bugs while working through these missions, or things that are confusing, things that can be clarified, I welcome you to create an account on the OpenHatch bug tracker and open a bug report. Perfect, great. Oh, so then you said the same problem with a Mac, so then maybe we should update, someone could update this ticket then to say that this is also a problem on OS X, if it doesn't already say so. Okay, cool. Yeah, so the place where you can paste code if you want to share it on, or there are a bunch of places where you can paste code if you want to share it on IRC. A really common one is Pastebin. We have some other folks. All right, folks, brief interjection. So we are at our break period. So it's 11, not 11, 11, 12, 1, 2, 2:55 East Coast time. It's 2:55, and we want to pick back up at 3:10. So please, so break time for about 15 minutes. Please be back here by 3:10. You're welcome to continue working through this material. It's okay if you haven't finished. It's going to continue to be online. The next thing that we're going to do is contribute to some projects on GitHub together. So like actually like making changes and then submitting them to someone for review on GitHub. So that will be very fun. We're going to pick up with that after the break. Please at least stand up. So like a little of this for the next 15 minutes. Bathroom. I think there's snacks outside too. Okay, 3:10. Back here at 3:10. Does anyone have any questions in the room while we are waiting for people to trickle back in? Excellent, good. Let us move on to sort of the next layer in our journey. So we have this tool called diff, we have this tool called patch, this sort of fundamental format for representing changes. And we also have this version control system called Git, which we use to manage source code and collaborate on source code together. As of the last couple of years, there's a really popular company and project around contributing to open source software called GitHub. And GitHub is not the same as Git. So Git is a version control system, and GitHub is a company and a place where you can host and easily sort of advertise your open source projects. And we had you create an account because it's a really popular place to store your projects, and they have a slightly different and kind of interesting and fun way to collaborate. It's a sort of a layer on top of these underlying tools. And so to explore this GitHub model, and the model is called using pull requests, and we'll see why that is in a second. So this model of using pull requests rather than the underlying diff and patch utilities, we're going to explore this through working together on a GitHub project, so a project that is stored in the Git version control system that lives on GitHub. So I'm going to take this URL, and I'm going to paste it into IRC so you all can copy it easily. And if you could please copy that URL into your web browser. It's going to take you to a page that looks like this. And this is just source code. It's just text. in the Git repository that is sort of nicely being displayed for you online. And what we're going to do is we're going to follow the instructions. So you're going to go to this website, and you're literally going to go instruction by instruction through these instructions, and this is going to tell you how to use the GitHub model to make a change to this repository and ask me as the project owner to incorporate that change, basically to apply that diff to the repository so that everybody else can see that change as well. So without further ado, please visit the URL on IRC and then follow the instructions. And if you have any questions, definitely ask on IRC. We can zoom in, yeah. There, hopefully folks are actually looking at it on your computers, but
Yeah, if you're on IRC, you can just click right on one.
I can see, so what's cool is that I can see sort of in real time that you all are interacting with this project. Like I can see that several of you have already forked the project, and I probably if I refresh there will be even more.
Yep. Did you create the GitHub account?
Yeah.
All right, so go to your,
So that's mine.
yeah, to your username. You're going to replace the text there with whatever your GitHub username is. Looks like it's Jason.
Yep.
Yep. So just fill that in with your. Don't miss the your username in the instructions. That's where you should put the GitHub account name that you create.
Yeah, and I clarified this on IRC.
Oh, that's good. For instance, I would replace that with Adam S. That's my username.
Can you show me the desktop? Just go to the terminal window. Expose the file names.
So folks, brief interjection. I'm going to show you what this looks like on my end. So this is a project that I created, so that means I'm sort of the one who, I can grant other people this ability as well, but I'm the one who can sort of decide that changes can be merged into the main repository. So even though anybody can check out a copy of the code, you can clone the repository, sort of I get to decide what actually gets committed and that then pushed out to everybody else. So, so you all have forked the project, which is awesome. Here we go, lots of forks. And then the instructions had you, after doing that and checking out a copy of the repository locally on your machine, you add a new file that has sort of a unique name based on your name, and then you add some text to that file. And you make that change locally, and then you push your changes sort of out to the world, out to the central repository. And that makes these changes sort of visible to everyone on the web as well. And like if you refresh your forked copy of the project in the web, you'll see that your commits are reflected. And then it asks you to initiate a pull request. And a pull request is like the GitHub high-level analog of you posting a patch or a diff on an issue tracker. It sends me an email saying, hey, Deb created this change, here's what it looks like, would you like to apply it? And the underlying format is the same. It's still just a diff, we're still just using Git, but there's sort of some gloss on top of it using the GitHub pull request model. And so I get an email, and we also see sort of an indication in the web UI that some people are opening pull requests. And so I can go ahead and take a look at one of these. And I can look at it in the web if I want. Like I can look at the commit, I can look at the name, I can look at the files changed. We see that plus sign, because this is the diff format, just sort of displayed nicely. And I can decide to apply this change, which is exactly the same as using that patch utility to apply the diff to the repository, just through a nice one-click web interface. And that's what merging the pull request means, applying this diff to the code base. So I can click merge pull request, I could add some additional commentary if I wanted, confirm the merge, and then, having done that, that commit is now part of the code. So like this is now part of the code, and anybody who were to check out my project now would see this file as well. So I'm going to, keep going through. If you haven't issued the pull request yet, keep checking through, and I'm going to approve all of them, and then we can take a look at what the commits look like, what the history looks like. Michelle is. Yeah. Okay, and we have a little addendum. So there's a git pull -- rebase, sort of the finale command that will pull in all of your changes. We have a slight tweak to that actual command, and actually someone could make that change and issue a pull request on the repository to make the documentation change. So Michelle's going to paste that into IRC in a second. And what this change will do is, well, it'll actually enable you to pull in the changes from the sort of the master repository, so you see them reflected in your forked copy. Interesting. It's possible that Freenode is a little stressed out by how many people are from here are on it right now, although we tried to have the conference fix that. Some people are also hanging out here on oftc.net, which a helper can help you get on.
And it's fine. If you're comfortable doing it, feel free to do it. No, you can't store it. You can always log into your GitHub account and just delete it. So you can't store it. So you can go ahead and do it if you want. It's all, the instructions are, but just, I apologize, but it's literally, I mean, I don't know if there's a way for you to update your version of Git using the ability you've got going on there. So if there is, maybe that solves the problem, but this is about, that's unexpected. There's a bug in the Windows version of Git 1.85 that prevents you from using usernames with HTTPS.
Oh my god. Okay, awesome. Okay, as we're going to get some of this documentation tweaked imminently, but in the meantime, I think I've merged all of the pull requests that were outstanding. So having done that, if we take a look at sort of my master copy of the repository, which you can visit in the web, or re-download, or re-clone, we see that we have lots of new files now. Awesome. And if you're curious, you can see where people are from and what they're interested in doing. It's a good-looking group of people. Awesome. And we can also see that there's some nice web polish, but this is still fundamentally just Git and its commits and its diffs. Like there's no real difference from the underlying tools. So we could look at a specific commit, for example, and we see that it's just this diff, this succinct diff format being applied to the repository. And so this is the GitHub model, the idea that you clone copies of the repository, or really you fork a copy of a repository, make your changes in your version, and then communicate the diff to someone using a pull request. Does anyone have any questions about this model of contribution? I would say that this is a pretty trendy way of doing things right now. Trends change really quickly, but currently GitHub is a very popular way of doing this. And like, for example, Django uses GitHub. It's their primary. This is where they host their source code. Cool. Yes?
So it's just a matter of forking an open source project and doing a pull request or a push request.
Yeah, exactly. So if the project is hosted, if the project uses Git and is hosted on GitHub, you can fork the project, make your changes in your forked copy of the project, and then use a pull request to communicate that you have made changes that you want to get merged back into the main project. Yeah, exactly. Any other questions?
What if they only want to approve part of your changes?
Ah, that's a good question. Like, what if you've made a bunch of changes in your pull request and they only want to use some of them? As you explore Git more, you'll find that you have pretty fine-grained tools for sort of selectively applying these changes. And part of why this is possible is because the underlying model is really simple. It is still just that diff format. So you have this diff format that maybe shows some changes in a variety of files, and you can sort of, you can carve out the ones that you care about. And the cool thing about the Git model is that you can actually, instead of just giving you a single giant patch, I can really send you sort of a series of patches represented by a series of commits, where each one contains like a single logical change. So like maybe I'm working on a big feature, and like the first thing I do is I add some underlying support mechanism for the feature, and then I add the feature, and then I add some tests, and then I add some documentation. I might do a single pull request containing several commits, each one containing each of these pieces of the puzzle. Cool. Okay, so GitHub model, cool. At least we're not munging around with diff and patch at the command line. That's pretty good. We have another sort of way to practice on GitHub. We have another project to practice with. So we've done this one. But now we can practice making a sort of a more substantial change. And we have 2 projects that we can use, also hosted on GitHub, to practice actually, opening a bug report and patching, making a code change to a project. Here are the URLs. I'll post them again, but I want to point out that the username is different. This is another, like a test user that I created for the purpose of demonstrating these projects called justtest. So just keep that in mind. So we have 2 projects, Colorwall and Wordplay, and I'm actually going to demo the bugs for you right now. So let's see here. So first is Colorwall. So Colorwall is this nice little Python project for demonstrating little graphical effects. And it's actually pretty small, but there's some cool effects here. But there's a problem with one of the effects, which is that the letters that it's displaying are tilted on their side. So in the letter test, which is the very first effect that runs, the letters are sideways. And so one of our bug fixes is to make it so they're pointing straight up. There are lots of other interesting effects for this color wall. So that's one of them. So the color wall bug is that the letters are tilted on their sides. And then there's another project, this Wordplay project, and we've actually seen this Scrabble cheater before. And the bug in this project is that while the Scrabble cheater works for lowercase letters, so the rack that you provide on the command line, so this works, but uppercase letters don't. And that's not very intuitive for users, so that's a bug and we want to fix it. Okay, so here are 2 bugs in these 2 open source projects. And our goal here is twofold. Our goal is to first report the bug and then to supply the patch using this pull request model. So here are our bugs, just to restate them. And the first thing we're going to do is deal with the Colorwall project. So, and we're all going to do the same task. So even though normally you don't want to duplicate bug reports, for the purpose of practicing, we're all going to open our own bug reports expressing this Colorwall bug, the letters are tilted, keeping in mind what makes a good bug report. So if you could please, and I'll post this in IRC, visit this URL to take a look at the Colorwall repository, and there's an issue tracker in line with that repository, and there you're going to report that bug. So the first thing that we want to do is open a bug report. So if we go to this URL, and then at the right we have an issues link. So if we click on this, that will give us the ability to create a new issue. Oops. And then after you do that, the next step is in fact to fork the repository. So just like we did previously, you're going to fork the repo, replacing this with your actual username, and then you're going to make the changes in your forked copy, which will then push upstream. Yes.
One thing GitHub lets you do is upload a screenshot.
Adam's really pulling for the screenshot. If you want to go above and beyond and supply a screenshot.
I mean, if it's a graphical program, how else are you going to show it?
So after you've opened the issue, you're going to fork the repository and clone your forked copy of the repository. And I've copied these instructions into IRC as well. And then after you have forked the repository and cloned it, we're going to fix it. And here are step-by-step instructions for fixing this specific bug. And so this is the diff that you want to emulate. So currently, something either on our network or around GitHub is freaking out a little bit right now in a way that's losing our CSS styling. If this happens to you, it's not just you, it's also happening to me. This makes it a little bit hard to show you what merging this stuff will look like, but we'll work it out. Anyway, it's not just you. How are people doing on this process? Yeah? Questions? All right, folks. If you are continuing to work on this, great. I'm going to quickly flip to if you are done with this and want to do the next one, the wordplay one. The model is going to be very similar. The plan is to issue the on this repository, which I'll paste in IRC. First, open the issue, then fork the project, then clone your fork, and then make your change and issue a pull request. So exact same model, make the, open the issue, fork the project, clone the project, make your fix, issue pull request. I'm gonna paste in the color wall stuff into IRC so we can keep working on it in IRC, and then I'm gonna show the wordplay stuff up here so that people can see both at the same time, depending on what you're looking in. Okay, so color wall, good, good, good. Wall or wordplay or some of the historical content or some of the bonus material. Everyone hopefully has something to work on. Raise your hand if you don't. How are folks doing on these pull requests? Questions on color wall? Questions on wordplay? There was an addendum to the instructions that I think Adam posted to IRC, which is that when you git add, you need to actually git add a particular file. So even my instructions erroneously just said git add. You actually need to specify a particular file. So that hung up anybody. Yes. The PDF, yeah. Raise your hand if you're done with color wall. Raise your hand if you're done with wordplay. Cool. Okay, so people are still doodling around with both of these. Great. We'll spend a couple more minutes on this. And if you're done, we have that bonus material for you as well. Use if I All right, folks, this stuff is gonna continue to live online. These slides I'm gonna send out as part of the wrap-up material. We are gonna switch gears so we can cover one more topic before we wrap up. But before I do that, does anybody have any questions about the GitHub model for things? You know, the specific commands, you know, will eventually, they'll become second nature eventually, but this general model of there's a project, you fork it, you clone it, you make your changes, you run the tests, they pass, you issue a pull request, it goes in this review cycle, and then it gets merged. You know, that is the model. And this model is you know, the underlying technology is still good old diff and patch, but with some nice tools on top of it that make it a little bit easier. So do people understand sort of the underlying model and the general flow with GitHub pull requests? Cool. Okay, so we have one more cool thing that I want to share. And we're going to just talk about this at a high level because we only have so much that we can cover in a single 3-hour tutorial. But hopefully you can take it home with you and play around with this a little bit. So the main way that we've talked about sharing things is through a repository. Like you put your code in a version control system, and maybe you host it on GitHub, and that way other people can find it and they can contribute to it with you. A related concept is, hey, if you've written some code that could be really useful to other people, they want to be able to install it, like they install Django, or like they install Python, by making it, well, not Python, like Django, or what, the Python Twitter module, or you know, any of these other packages that you've installed, by making them actual Python packages that you could easy install or pip install or however it is that you install things on your system. So I've created a little toy project based around that Scrabble cheater that is an example of a Python package. And this is it's just Python code with some packaging metadata hosted on GitHub in a Git repository. So I'll post this link into IRC so people can check it out. And if you want, you can clone this repository if you want to take a look locally, or you could even fork it and clone it if you think you're going to make a change back to it. And so as you do that, I'm going to look at the project locally, so my local checkout of this Scrabble repository. And if we take a look, we see that if we look in the Scrabble directory, we have a Python file, this init file, and we have a text file, sowpods.txt. Sowpods.txt is just a word list that this Scrabble module uses. And this init file is part of how you describe a package, and it contains the code for the module. Pretty short. All this module really does is it gives you a word list and a Scrabble tile score dictionary. So a really simple module. And also as part of this package, so there's this module that once we install this package, you could import Scrabble and then use the Scrabble logic. There's also a script. So there's this Scrabble cheater, which is exactly like the Scrabble cheater that we saw earlier, that you can run as like a standalone script. And we just have to do a little bit of work to turn this into a package. So the first part of it is that there's sort of the way that this is structured to have a package. So the fact that there's this Scrabble directory that contains an init file is part of the structure of packages. And then we have a license file that describes how other people can use the software. And we have a README that helps people understand how to use the software. And we have a manifest file that describes some of the files that we should make sure are included when you install it. And then we have a setup.py. Also pretty short. It describes the name of the package, a version, some data on the author, if there are any scripts involved, and if there's any sort of non.py file package data. In particular, that sowpods.txt word list. So that's all that there is in this setup file. And this is enough for the Python packaging ecosystem to know how to generate a package from this. And so the way that I would generate a package is I would I think this is what I would run. I would run a particular command out of setup.py. So setup.py is part of the framework, and you can provide arguments to setup.py that say, hey, I would like to produce a package from this. In this case, we'd use this sdist command line argument. And this will do some work that generates inside a build directory, maybe inside a dist directory, an egg and a tarball for my module. And so if you've ever installed something like sudo easy install Twitter, this is what you're installing. You're installing something like an egg or something like a tarball. And I could even take this. I could copy this into a temp directory. Oops. And I could unpack it. Using that tar command, which some of us played with earlier today. So you really do use tar sometimes in real life. And then I could install it. So if you've ever manually installed a Python package, I navigate into the package directory, and then I sudo python setup.py install it. And all that installing Python software does is it puts the code in a particular place in your file system where Python knows to look for it. It's just Python code in a special place, and that's all that a module is. So if I do this, and then I could, in a new terminal, I could now import Scrabble. Oops, Scrabble. Hey, so this module that I wrote, I can import from anywhere. And if I put this on GitHub, other people can download it, and they can install it too. Or I could even, with a little bit of extra work, I could put it on PyPI so that you can easy install it. So this is all that there is to Python packages. It's actually a pretty lightweight wrapper around just some Python code. So I have my Scrabble word list, which is a lot of words. Scrabble players, they like having lots of words to be able to use when they have crappy racks. And then there's also this Scrabble cheater Python program, which I can run from the command line. Cool. And so all of the code for that is in a pretty simple repository on GitHub, which you all can check out and improve if you want. And that is it. So a setup.py file with a little bit of metadata, and a license file and a manifest file, and then my code with a little bit of structure that reflects the way that packages look. And that is it. So if you've ever wondered how a Python package is created, there's very little magic to it. Here's a really good template if you want to package. If you have software that you've ever wanted to share with the world, here's how it works. Does anyone have any questions about Python packages?
Are there any tools for creating the Python file with all the...
Oh, like with the setup.py file? I'm not sure. It's pretty minimal, so I'm not sure if there are tools that help automate it. You can get these things can get pretty fancy. Like you can specify dependencies and things like that depending on what package generation tool you're using. Yeah, cool. Other questions? Things you want to package? Now that you know how to do this? Cool. Oh, no, I haven't actually put this on PyPI, although I could. If lots of people would like a module for assisting you at cheating at Scrabble, I definitely could do this. Cool. So pip and easy install are two package management frameworks in Python, and they are basically the same. There is some associated metadata, but fundamentally the way that you create the packages is it's effectively the same, and they're all hosted in the same place. Like you upload them to PyPI, and easy install and pip both pull from PyPI. Yeah. Where when I say PyPI, this is what I'm talking about. So when you easy install Django, it's fetching it from PyPI or a mirror. So it's just a centralized repository of all of the Python packages. And as you can see, there are a lot of them. I think you need to sign up. Like there's some account management associated with doing this, but like we could all upload PyPI packages today if we wanted after registering. Definitely. Yes. So you and I can put basically whatever we want on PyPI. I mean, there's some amount of like, if people put malicious things, or actually malicious is very unusual, but a thing that occasionally happens is people like try to use PyPI as a place to store really large files. Like if you try to do that, the maintainers might remove the package. But other than that, no, this is a community service, and if you have something that is in Python that you want to share with the world, you can put it on PyPI. Other questions? Okay, we're in the home stretch. Okay, so part 3 in summary. Okay, pop quiz. What is the difference between Git and GitHub? Yeah.
Git is a version control system, and GitHub is a website that hosts Git repositories.
Exactly, beautiful. There are many version control systems. Git is one of them. We saw that Python uses this thing called Mercurial. There are also many websites that will help you host your repositories for your various version control systems. So Git is one type of version control system. GitHub is one of the many websites. Good to keep that in mind. We've seen 2 contribution models. One is sort of focused around the underlying tool. So maybe you open an issue on an issue tracker, and you say, hey, I'm going to fix the bug, and you check out a copy of the source code, you make your changes, you use that diff utility to create a succinct summary of your changes, and maybe you attach that diff to the issue, to the ticket. And then someone will take that diff and apply it with patch, and then review your changes, make sure they pass the test, etc. So this is sort of that most basic model. And then we also saw this model that's sort of layered on top of it that GitHub likes, which deals with pull requests. So same underlying tools, but we're instead sort of focusing at the Git commit level, and it's more about sharing changes through GitHub's web interface. And then there's also a little bit about Python packages, mostly to point out that there's very little magic here, and we could all create Python packages if we want. Not hard at all. Any questions about part 3? Cool. Okay. Well then, what is next? We have covered a lot of really good material here. And it doesn't have to all be rock solid yet, but this exposure to the general landscape, the general process, I think the next time you have to do this, a lot of this is going to look really familiar, and you're going to be like, hey, I've basically done this before. Awesome. There are a lot of things you can do coming out of this class right here at PyCon. Monday through Thursday are development sprints. So your favorite Python projects, Python, Django, Twisted, PyPy, they're all, a bunch of folks from those projects are sprinting in person here at PyCon, Monday through Thursday. This would be a really great opportunity to get started with contributing, because you have people like right here in front of you who can help you get started. Even if you're leaving PyCon early, it's still a great opportunity because there's like a real density of people who are focusing on the project for the next couple of days. And as we know, they're all going to be using IRC to talk anyway, so hop on the IRC channel for your favorite open source project and get started. Pick a bug to work on, and people would love to have you help. So there's a sort of a list of all of the sprints on the PyCon website. Another cool thing is that, in particular, bigger, more established projects, they really want new contributors. And so they have really good documentation for getting onboarded, and they've even pulled out sort of bite-sized tasks that are particularly good for first-time contributors. So a couple of examples are from Python, Django, and Twisted for their sort of beginner-friendly tickets. I would also strongly encourage everyone to use a site like GitHub to host all of those projects that you have laying around on your computer that are hiding from the world. This is for a number of reasons. One is that sharing your code is great. Like, you've probably written code that would be helpful to other people. So why don't you put it out there in the world on GitHub for people to use? It's also really great sort of as an open source resume, as we talked about earlier. The number one thing that I look for when I'm hiring people is like actual concrete evidence that they are good at contributing in a collaborative environment to software. And like, there's no better signal for that than you having contributed to stuff on GitHub. So it's good for your credentials. I would recommend that folks pick a specific project. Let's leave the abstract land for a second and say, hey, what is a project that you would like to contribute to? Maybe you really want to contribute to Python itself. Maybe you use Django at work and you want to work on Django. Like, I don't care what the project is. Maybe you love Twitter, work on the Python Twitter bindings. Pick a specific project, go through their new contributor documentation, pick a bug, hop on IRC, and get started. If you do want to work on Python, there's a specific mentorship mailing list that is specifically for helping onboard first-time contributors. So a really friendly bunch there. I'm also on that mailing list if you want to get started with Python specifically. I'll also call out Django for having like exceptionally detailed new contributor documentation. And if you're looking for suggestions for new projects to work on, there are two sort of good sources of positive signal that I would recommend. If you've heard of Google Summer of Code, this is a way for college students to get paid to work on open source software for a summer. And the GNOME Outreach program is sort of similar, but it's not restricted to students, and it focuses on contributions from women. And I call out these programs because you have to be pretty with it as a project to be accepted into these programs. And so they're going to have good documentation. They're going to have bite-sized bugs from new contributors. Like, they have the setup, they have the infrastructure, they have the mentorship infrastructure. So they're a good place. So the projects that participate in these programs are also a good first choice for contribution. Yeah, so you know the drill. I mean, we've gone through this whole cycle. We know exactly what the bug life cycle is. You know, get onboarded, check out the source code, join the IRC channel. There are going to be open bugs and open feature tickets on the issue tracker. Pick one. You've got the source code. You know, create the diff, run the test, do the pull request. You have all the tools that you need now for sure. If you ever have any questions, in particular any process questions along the way, this site that we've been using for the training missions, OpenHatch, as I mentioned, it's a nonprofit whose whole philosophy is let's lower the barriers to entry to open source contribution. And they have an IRC channel. So if you ever get stuck or you just need like a pat on the shoulder because you're suffering through some Windows bugs or whatever, hop on the OpenHatch IRC channel on Freenode, and people would love to just chat with you about what's going on. And that is my pitch to you. So we have all the tools that we need to, like, leaving this room today, put our code on GitHub, contribute to open source projects, package our own Python projects. So we've covered a lot of really good material in just 3 hours. I think contributing to open source is tremendously rewarding for me personally, and I hope that you all will join me this weekend and in your broader open source careers and investing in this community. So that is my pitch to you. Does anyone have any questions about anything that we've covered today? Yes, that's an excellent question. How do you choose a bug? Like, say I know I want to work on Python, but geez Louise, there's a lot going on there. One good way is to talk to people. Like, you hop on IRC, you say, hey, I'm new, kind of overwhelming, like, just tell me a bug to work on. A lot of these projects have easy bugs or bite-sized bugs, picking one from that list. For Python specifically, I've written up some really detailed contribution and triage instructions, which are linked from the bonus material, just to get a sense of what these look like. It's like very, very step-by-step annotations on how to get started with triaging things. A lot of this stuff we've covered before, as you can see. And part of what we did for this project is we actually pulled out some, we pulled out more of these bite-sized bugs. So I think bite-sized bugs, talking to people on IRC is the best way to get started. I mean, the flip side is, if there's a bug that like personally affects you, that particularly motivates you to work on it. Yeah. Yeah.
I've read that a recommended steps in order to contribute is usually doing like being able to test and then afterwards maybe writing some tests or documentation and then fixing bugs and afterwards perhaps features. Would you agree with that, or would just like bite-sized bugs are good to start with?
Yeah, so the question was, I could work on some tests, like work on some documentation as I sort of build up expertise in this code base. It's ultimately sort of whatever makes you most comfortable. Yeah, I think documentation is a great way to start. I think tweaking tests is a great way to start. I would say that like tackling large features would not be a great way to start, but any small self-contained thing, be it documentation, be it a test tweak, be it a small bug fix, those are all good, yeah. And remember, there are lots of ways to contribute. So there's code, there's documentation, there's triage, there's helping people in IRC. Maybe they really need a new logo. Maybe they need translations. You know, there are lots of capacities in which we can all contribute. Everyone have a clear next step? What are you going to contribute to at the sprints? I'm going to contribute to Python. Yeah. I will be at the sprints on Monday if people want to hang out with me, provide moral support. When the sprints, well, you know, Monday, it's like when people roll out of bed, I'm going to be totally honest. Like, by the end of Sunday, people are pretty spent on PyCon, so people are sleeping in. But if you hop on IRC, people will be talking. If you hop on PyCon, if you want to, like, Python dev, people will, hey, I just woke up, I'm heading to the convention center. Yeah. Final questions? Concerns? Words of encouragement? Okay, what words of encouragement? Some Windows folks have sort of suffered a little bit today. You all are in such demand. Like, if you have a project that you want to contribute to and you're like, hey, I'm on Windows and I have all these problems, people want to hear that. Like, there are not enough, like, the proportion of Windows developers from most open source projects, like, or the ratio to the users who are on Windows is, like, way imbalanced. So there are not enough Windows-focused open source developers given how many people use open source projects on Windows. Like, you are a hot commodity, so people want to talk to you, I promise. Anything else?
How do you find IRC channels that are relevant?
Good question. You can technically generate a list of all the channels on Freenode. I think it's like several thousand. Typically, you have a particular project in mind, and they document in their sort of communication guidelines the IRC channel. So like in the Python developer docs, it says, hey, we use Python dev on IRC.
Yeah, you can Google it, and sometimes you can guess. Like, the PyCon channel is not, like, if you didn't know that there was a PyCon channel, but you suspected there was, it's named PyCon, so
Yeah, and Freenode is far and away the most popular network for this stuff. Hop on Freenode, join the channel, see if anybody's in it. You can create your own channels, as I mentioned earlier, if you're starting an open source project. You can be on IRC, ready to help out your users. Anything else? Okay, I think we're all set. Thank you all so much for coming. All of this stuff is going to be online in perpetuity. I'm going to send you an email with links to all of this stuff and to the PDF. Thank you again, and have a great rest of PyCon. Yay.